Hi, I'm Bruce Eckel,
Hi, I'm James Ward.
and this is the ActionScript chapter of First Steps in Flex. So the first thing is, what is ActionScript? It looks a lot like JavaScript.
It does. Future versions, or past versions of ActionScript were actually a derivation of JavaScript. So that's kind of where it got its roots. But in ActionScript 3, it did a lot to evolve the language to really make it much more of a real programming language with object-oriented features, some metadata features, and just other things that programmers, Java programmers, .NET programmers are familiar with.
So has it diverged from ActionScript or ECMAScript at this point?
It did diverge from the specification. Adobe was working on a new specification with the ECMA committee that would have standardized this new version of ActionScript or some part of it, but that has been stalled for a little while the browser vendors decided to do a little more incremental change to JavaScript.
But now I thought that all the JavaScript cross-browser problems were solved with all these Ajax libraries and all these other libraries.
Well, there is a specification that all browsers try to abide by when they implement JavaScript, but they all still have some subtle differences.
But don't the libraries solve those problems?
They can. In some cases, they just create different versions of things for different browsers and that sort of thing. But it's still not 100% compatibility.
Oh, so if you if you're writing JavaScript, you're always going to have to tweak it for one browser or another.
Or you potentially could have a tool that does that for you.
I see.
Right.
But now if I'm writing ActionScript, I don't have to care about what platform I'm working on?
Well, there's one runtime, Flash Player, which is the only runtime for ActionScript.
Okay. So it's really kind of a write once, run everywhere.
If everywhere includes Flash Player.
Okay.
Which is essentially everywhere.
All right. So, well, that seems like it makes it easier anyway. Well, usually when you start talking about a programming language, the first place that everybody goes is variable declarations. So let's have a look at what variable declarations are.
Yeah, let's take a look. So let's go create a new Flex project here in Flex Builder. So then let's just call this one ActionScript, like the chapter.
Okay.
So, and if you're joining us for the first time, we're using Flex Builder standalone to build these applications. You can also use Flex Builder as a plugin to Eclipse. You could use the open source Flex SDK. So there's lots of different ways to build these Flex applications.
And in our examples, we've been removing the layout equals absolute tag.
We have been.
And just letting it go to the default layout.
Which is vertical.
Okay, so, well, probably the most obvious variable to create, type to create is a string. So let's call them word. Let's create a string type that it's a word. So
before we do that, let's talk about how we can do ActionScript. So we can do ActionScript in two ways. In the Flex programming model, you have MXML files, which are declarative, and you have ActionScript files, .as files, that are just ActionScript. But MXML files can also include ActionScript code. And so that's what we're going to be doing here is actually, we're not going to be creating a whole separate class in ActionScript. We're just going to embed some ActionScript code into this MXML file. And what's really happening in Flex is that the MXML gets converted from MXML down into ActionScript at compile time. And so then the ActionScript that we're going to write is just going to be inserted into the ActionScript class. And then in the Flex SDK, the compiler converts all the generated ActionScript and the ActionScript that developers write down into the bytecode for Flash Player.
Right, and we'll look at that a little later so people can see how much work MXML actually does for you and why it's kind of a compelling way to do things.
So, and then one other point on that is that anything that you can do, anything that you do in MXML in ActionScript could be more work, but not the other way around. There isn't 100% equivalence between ActionScript and MXML. such as is no for loop, or there is no none of these procedural types of language constructs in MXML. MXML is purely declarative, so all we can do is declare things.
So for that reason, it makes sense to periodically drop into ActionScript.
Exactly. Yeah. Because if MXML did have these procedural tags, then we wouldn't really need ActionScript. We could always just stay in MXML.
So how do we drop into ActionScript from MXML? Great
question. So one way to do that is to add a script block to our class. Okay. So this is an MXML class. We've just created a script block. So now the code that we put in here will essentially be code that's kind of in the class scope. So if we define a variable here, it's going to be in the scope of the class.
Now what is the class? I don't see any class definition.
So the class, so in MXML, our class is named whatever our file is named. So in this case, our class is named ActionScript.
So under the covers, it's creating a new class called ActionScript.
Yeah. And the first tag in MXML is going to be the class that this class extends. So you can think of the ActionScript that's actually going to be written behind the scenes here is going to be public class ActionScript extends application.
Okay.
Okay.
So what you're saying that because when we're defining variables, those are going to be actually fields of our new class that we're.
They will be what do we call them? Properties on the class or
fields or or members.
Members. That's
depending on what language you're referring to.
So these will be members on the class. Mm-hmm. Exactly.
Okay, so let's create a variable. word 1 and word 2.
Okay.
And we'll treat them differently.
So are these going to be, what namespace will they use?
Just the well, what happens if you don't? Let's just try.
Okay, so let's just create a var.
Create a var.
Okay.
And then call it word.
Word.
And what type is it?
And its type is string. So we should point out that the colon specifies the type. And these are optional, actually. In ActionScript, we don't necessarily have to specify the type, but we'll start by specifying the type here, and then we'll show what happens if you leave it out.
Okay. Okay. So what happens when you
And that's all we want to do.
Well, for now.
Okay. So let's save that.
Save that. And
so
there's a warning.
Things compiled, but we got a warning saying var word will be scoped to the default namespace, which is ActionScript internal. It will not be visible outside of this package. So just like in many other languages, there are things that you can set on your variables to specify their scope. So in Java, for instance, public, private, protected.
But Java also has a default namespace, which works exactly the same way. It says it's package.
Right. It's package scope.
Yeah, package scope. Okay, so it's the same here, but I mean, why is it giving us this warning?
It likes us to specify a namespace. We don't have to.
So is there any way to say this has package scope without getting the warning?
So the scopes that we can specify out of the box are public, private, and protected. And then I've never tried to do internal, but let's see if there is an actual internal. It's saying it's ActionScript internal, but I don't know if we can actually. No, we can't actually use that. And we'll see one interesting thing here is that we call these namespaces actually. So the public, private, and protected are actually namespaces that we're defining. So when we are going to set public, private, protected, or something else in front of this, it's actually setting the namespace for this variable.
Okay, so what happens if we set it to private?
Let's set it to private. Save. Okay, now our warning goes away.
Go away.
So and here's the interesting thing to point out about namespaces is that public, private, and protected are the ones that are available just out of the box, or just part of the core ActionScript language. But you can also create your own.
Really?
Yeah. And so if you did want to use another namespace, you can say use namespace, and then specify the name of the namespace.
And where does that have to be defined?
I think that has to be defined on our class. If we're in a script block in MXML, I'm not sure if we can just put it here or if it has to be in somewhere else. Namespace. Okay, so we can't just put it there.
It has to be found. Now, why would you define your own namespace? What the point of that?
So, for instance, in the Flex SDK, they use this namespace MX internal quite a bit. The reason why they created their own namespace for some variables is they didn't want them to be private and they didn't want them to be protected, because protected kind of assumes that there's essentially a public API there that will not change really. That you're gonna almost guarantee that things are not going to change very much in that protected or the public namespaces.
Because if you inherit from a class with protected fields, then you have access.
Available. Yeah, exactly.
Right.
And so they created this MX internal namespace for things that they wanted to allow you the ability to have access to, but they wanted it to be in a separate namespace so that you'd essentially know that by using the MX internal namespace, you're going into something that could change, that they're not really guaranteeing is a public API with that will always be consistent.
Okay.
And so they used the MX internal namespace quite a bit, just as a way to provide you access, but you really have to know what you're doing, and that's you say use namespace MX internal, and so you're really kind of taking the risk. Then you're taking the risk that API could change.
Okay, so now we have defined a string variable here called word, but we haven't initialized it.
Nope, right now it's null.
What does it look like? Let's create another word. Let's call it word1, where we initialize it to something.
So we're going to make this equal to, what should we
Let's say 'twas Brillig, since that was the...
was...
Brillig. This is from the Jabberwocky poem.
Okay, 'twas Brillig.
Okay, and it likes that? It's happy with that?
Yep, let's save it.
Okay,
Looks
now it also has... You can also initialize it as we do in Java by calling new and with the constructor. So you can say new string, and then slithy toves was the
slithy
THY. Yeah, it's Lewis Carroll. So TOVES. Okay.
There we go.
Okay, so the
well.
first form is an abbreviation which is special for strings, and the second form is the kind of thing that you'll see with most objects, because most objects you have to call the constructor, and the first form calls the constructor for you.
Exactly.
So that's fine.
Yep. And one thing to point out here that's kind of interesting is that we've just created these variables or members on this class, and then we actually have these default values for them. And in the case of this one, it's kind of strange because you're wondering, all right, when does this new string actually happen in code execution? Because this is actually set, essentially on not within any executable block of code, really.
And I see no event.
Right. There's nothing that's firing this code to execute, and no event. So it kind of begs the question: when does this actually get set? And I believe that the answer is that the stuff that we set here in this way actually gets set on a static initializer for the class. So whenever you initialize an instance of this class, it's going to run through and actually set these values on this property.
Is static initialization an event, or is that just something?
No, just something that happens when the class gets instantiated.
Okay. Well, okay, so we now have some strings, but I always like to prove that they exist. So maybe we could make some labels and display the values of those strings.
Yep. So we're going to set the label text, and we're going to use data binding. How are we going to, what's the method of moving that property?
Well, can't you just say the name of the variable?
Yep, so with data binding, what we can do is say let's bind the string into this property. So it's going to watch that word string. Whenever word changes, it will then update this text property.
Okay, so what happens when you...
So when we save this, we're going to get a warning saying data binding will not be able to detect assignments to word. The reason for that is that we have to specify variables that are defined in ActionScript to be bindable, or we will get this warning. And without specifying that they will be bindable, without specifying them to be bindable, then the data binding event infrastructure isn't set up, and that's why we get the warning.
But will it still display something when we run it?
It could potentially. Let's give it a try. And we're gonna have to do word 1 since word is essentially doesn't have a value. So, and while we're at it, let's just add word 2 as well.
Okay. And then just
so and we're getting all 3 warnings now. So let's run this one and see what happens. There we go. Okay. So first one, not showing anything. It's essentially null. Second one is twas brillig, and then slightly toes.
Okay. So it works, but
it
never changes. So the warnings are not really that. Of course, it's not a very. It's kind of a weird example anyway.
So and I think in the book we use consts, right? Somewhere.
We use private. We say private const word string.
Okay.
And I think that makes the warning go away.
Yes, it should, because binding to a const, we don't need to detect changes. We don't need to check changes on these variables because they're consts, not vars. And so that's why the data binding, the warnings on the data binding disappeared, but now we do get a warning on this one saying that it was never initialized, and that's...
So to get rid of that warning, could we say equals null or none or whatever it is? And now it's been initialized. Yep. So it's the same effect. It's just that we're explicit about it, so the warning goes away.
Right.
Okay. So this bindable sounds kind of interesting. If I make it bindable, then I can actually change things.
Definitely. Yeah, so let's change this example around so we can show the data binding. So you remember when we were using the vars, the binding wasn't working, essentially. It worked once, but if that value were to ever change, which variables should change, then that label would never update with the new value, because the infrastructure hadn't been set up for that variable to be bindable. So let's create a new variable here, and let's call it count. And we're going to change this from being a string to being a number. And we're going to initialize it to be 0.
And if I didn't initialize it to 0, would it be undefined, or?
Good question. We can try that. I think it's going to be not a number.
Oh, okay. Well, we can do that now.
Okay, so let's set our labels text now to be count. And then let's set an event handler. So when this label fires the update complete event, which happens, essentially anytime this thing gets redrawn.
Wait, now, which thing gets the label gets redrawn, or the whole screen gets redone?
The label. Once the label gets initialized, once it's fully kind of added to the display hierarchy and fully created, it's going to throw this update complete event. And so then what we're going to do is do count plus plus.
Now, where does it get its count information?
So count is our variable here.
Oh, and it can just see it.
Yep.
Okay.
Yeah, so any variable that we have in the class scope, we can access from an event handler, from ActionScript code, or in data binding expressions.
Okay, but we got a warning.
So we got a warning because data binding was still not able to detect assignments to count.
And if we run this, means it can't install the necessary wiring.
Right, exactly. Okay. And so while that backing variable count actually is 1, our label is not showing it as 1 because when it changed, it didn't dispatch the change event so that the label would know that the property changed and then update its view of that data. So in order to fix that, what we do is we set some metadata on this variable called bindable.
And the square brackets are what counted as metadata?
Yep, that's metadata. So this is similar to like a Java annotation. It's just some metadata used either at compile time or at runtime about this variable.
So effectively, you're telling the system some extra information that you want. Now, but why? Why can't the compiler just say, "Oh, you're trying to change this thing, so I'll make it bindable"? Why do I have to be explicit about it?
Yeah, so there's overhead in binding. It's very magical, it's firing all these events, watching all these properties, setting up all this infrastructure in order to support the data binding, but there's overhead to that. So that's why Flex forces you to specify what you want to be bindable, because you don't want to incur that overhead for every single property in the whole system.
I see. Could you make the font larger on the label?
Font size?
Yeah.
Yep, let's do that. Font size.
And do you remember all these things, or do you just say, oh, I'm trying to change the font, so I'll just start typing font and see what comes up?
Now I remember them, but at first when I was learning them, you look in the AS doc, you look
or
at code
you just
completion.
let code completion do it for you.
Yeah. Okay, so now that it's bindable, and let me show you one more thing about bindable. These metadata tags can either appear above the variable, or they can appear on the same line. Whichever way you want to do it, it's up to you. So let's save that now. Our warning has gone away, and if we reload this, now we'll see that it's just starting to count. The reason why it continues to count is that every time this text property changes, it's going to, after it's finished actually visually changing that what it's displaying, it's going to dispatch this update complete event, which is going to increment the count again, which is going to cause it to update. So it's this recursive loop happening where it continues to update count. Data binding triggers.
Is it actually recursive? Because wouldn't it blow up the stack at some point?
Because it's using the event model. Mm-hmm. It's essentially recursive, but it's recursing over loops of execution. So our frame rate in Flex is 45 by default or something like that. So what's actually happening is that about 45 times a second, this update complete is going to fire, and those are happening across frames. So they're not on the same stack.
So all it's doing is putting another event in the queue and then returning.
Essentially.
So that way it doesn't blow up the stack eventually.
Exactly.
Okay.
Exactly.
So that's pretty interesting.
Yep.
Okay. So we talked a little bit before that MXML always produces ActionScript.
Right.
I'd like to look a little bit more into that and see what code we might actually see. I mean, maybe it's not exactly the same, but basically what code would you have to write if you weren't using MXML?
Yeah. So let's go modify this, and let's close out that. I'm going to just create a basic label. I'm going to set the text on the label to be hello world. Okay. And so now we've got this basic label. Now let's remove our count here. We're not going to need that anymore. And run this and see how this looks.
I don't think you need the script either.
Okay. We'll use it in just a second so we can replicate what we've just done in MXML in ActionScript. So there we go. We're displaying our label hello world. So let's increase the font size on
how you do it there. Okay.
that 24. So that shows up a bit better. There we go. Hello world. Okay. So now let's see what code we would have to write to replicate these essentially 3 lines of MXML.
So you just put in another script block?
We could put it in a script block, but the problem, remember, with this script block is that code doesn't essentially get executed. It just gets added to the class. So what we need is some event that's going to actually execute some code that we write that's then going to add the label to the screen.
And how do you know what event that would be?
So you can pick a number of events. There's a component lifecycle, and you can choose when in that component lifecycle you want things to happen. The event we chose in the book was the initialize event. So what we're going to do is we're going to write some ActionScript code so that when this application initializes, that's just one part of the component lifecycle, we're going to create our label and then add it to the display list, the screen, essentially. So let's remove our label, so we only want one of them. So now in our initialize, first thing we're going to do is import the mx.controls.label class. Then we're going to create a new var, label of type label. Then we're just going to new it. So we initialize that label. Okay. Now we're going to set the label.text equal to hello world. And then we do this dot add child label.
Oh, now this is normally something you see in a method call.
So this essentially is in a method call. So our event handlers, they get wrapped into function closures that become functions on the class. So when this code compiles, it's going to take the action script that we write in here, and it's going to wrap it into a function, add that function onto the application, and then when the and then it's going to add an event listener on the application, and that listener for the initialize event will then fire that function that then runs this code.
So is it overriding some default initialize event?
No.
Oh,
no.
It's just creating a new one.
Yep, create a new one.
And
creating
now,
a new event handler on the initialize event.
We're inside of an event handler, so does that mean the import happens when the event is called?
So this import, I believe the compiler is going to be smart and is going to move this import into the class or into the package statement instead of having it in the function.
Because it just needs to see that to know what the label definition looks like.
Right, exactly.
Okay.
Yeah. Yep.
Okay, so
this code should do the same thing as we had before. Let's save it and test it and make sure. And we haven't set the font size yet, so it's back to a small font.
Okay. How would you set the font size in code?
So if we did want to set the font size programmatically, there's a little bit of a trick to it because styles, so components have properties, methods, events, and styles. And so font size isn't actually a property on this. If we try to hint font size, it's not going to show up. It's actually a style on the label. So in order to set a style, what we have to do is call setStyle, and then we're going to set the font size style to the value of 24. So now this should, there we go, now we get our font size, font is larger.
So basically all of these lines of code are what we have to write instead of writing the one-line ActionScript tag.
Right, yep.
Okay.
Yeah, so these 4 or 5 lines could be specified in one line of MXML. And that's really the benefit of MXML is just having a less verbose language to instantiate these objects, set properties on them, and then add them to the screen. That just inherently happens with visual components that you define in MXML.
So basically it's kind of a higher level declarative way of describing your user interface.
Yep.
Which is nice because user interfaces are kind of a declarative thing most of the time.
That's usually how we're familiar with writing them, especially if you're coming from the HTML world.
Okay. Well, now, pretty much every programming language has the ability to define functions. How do we do this in ActionScript?
Yep. So if we want to create a function, we're going to go back to the script block here. So in our script block, remember this is just code that's going to be added to this class. So what we want to add is a function that's going to handle a click event from a button. So first let's go add our button. So I'm going to add a button and I'm going to give it a label, click me, and then in a minute we'll add an event handler. So let's go define our function on this class. So what we're going to define is, first let's add a variable. So public, or no, let's do private var num clicks. So we're going to keep track of how many clicks have happened here, and we'll make this an int equal to 0. And now let's go add our function. So again, like variables, functions also have those namespaces. So we're going to create private function, call it handle click, and then say that it returns void. And now we're going to actually specify our function.
So the :void is defining the return type.
Yep, that's the return type from the function. Returns void, returns nothing. So now in this function, let's do numclicks ++. We're going to increment it, and then we're going to display with an alert the number of clicks. So we're going to do alert.show and say clicked plus num clicks plus times.
So num clicks are available inside of this method, right? Because where we define it above, it becomes part of the class again.
Yep.
Okay, so this is just like defining a class, and you've got a field or
member.
Yeah.
Yep.
And then a method. So it's implicitly passing this, I suppose?
Yeah, so functions that are defined on the class as members of the class will have this as a reference to the class.
And in this case, this would be a reference to
this ActionScript class that extends application.
Okay. Well, the instance.
Right.
Of
The
class.
instance of that.
It's currently being.
Exactly.
Okay.
Okay. So now we want to have some way to call this function. So what I'm going to do is set an event handler. So the event that we're handling is click, and we're going to call handle click.
Now, before you go on, let's change the font on this. Is this the same kind of thing that you do for labels?
So we can button also has a font size property.
Okay,
we
so
can change the font size of button to 24 as well.
Okay. All right.
Okay. So let's run it and see what happens here. We can just go back here and reload. So now we get our button, nice big button with 24-point font, and when we click me, it says clicked one times, click it again, click 2 times. So what's happening is that when this click event calls this handle click block of code, it then calls this function which increments numclicks variable and then does the alert to show how many times the button has been clicked.
Mm-hmm. Cool. All right, now handle click is an event handler, right?
That's right.
So don't event handlers normally, I mean, when an event occurs, doesn't it create an event and
it does.
Kind of hurl it around the system? And
yep.
So shouldn't handle click be able to know what that event is that called it?
Yep. Yeah, so this block of code is getting wrapped up into a function closure that has an event parameter on it. And so that event parameter we can then pass around. So let's say that we want to pass that event. We can just put it in as an argument, but then handle click must also take an argument. And so I believe in the book we had another example where we showed taking arguments, but this one we can skip to this one and show how to take the argument here as well. So this function, if we want to take an argument, we can do event : and then the type of event that we want to take, in this case event. We could make this also more kind of explicit. We know that this click event throws a mouse event, so now we can say, all right, I want to take a mouse event instead of just a plain old event.
Now, in the place where you call it, in the button definition, where does event come from? I mean, you just like pulled it out of thin air.
Yeah, it does seem strange. What's actually happening at compile time is this block of code is actually getting wrapped into a function that looks similar to this. So it's going to look similar to this. It's going to take a parameter that's going to get passed in by when this event function is called, and so then it's going to run this block of code, handle click, passing it that event that got passed into that function now over to another function.
So the event variable is always there whenever you are doing anything that has to do with events, that you can just, does it have to be called event, or can you call it EVT or something?
It has to be called event.
Okay, so it is a magic thing.
Right. We can call this one whatever we want.
Right.
But this one is actually being defined at compile time when that closure is created around that block of code.
Okay.
So that's inherent in every event handler in Flex has this inherent event property.
Well, okay, so what if I'm an object of some kind, and there's an object over there that I'm interested in when things happen to it. Can I kind of reach over and say, I'm interested in you? What I'd like to do is like I'd like to attach an event handler to this other object, whether it knows about it or not.
Right.
How do I do that?
Yeah. So what we want to do is a lot of times we want to kind of explicitly set our event handlers, right? That's what you're saying.
Mm-hmm.
So we want to, rather than define the event handler in MXML like we're doing here, we want at some point in time, in response to some event or something, explicitly set this event handler.
So I could do it dynamically then. I could say, oh, things have changed. Now I'm interested in this event. So I'll call this code.
Yep.
Okay.
So the way that we do that now is we say we need some event that's going to trigger us adding this event handler. So let's remove this from there and let's decide when we want to do that. So in this case, we're also going to need to give this button an ID so that we can reference it, because we need a reference to this instance of this button in order to be able to set that handler. And then just to be kind of consistent with the code in the book, let's move this button up here. And now we've got our script block. We're going to remove our numclicks event, numclicks variable. And we still have our handle click event, takes a mouse event, returns void, and we're going to do the same show, but now we're not going to tell it how many times it is clicked. We're going to just say click event. Okay, so we've just simplified things a little bit. So we've got our function that we want to call when that click event is triggered. So the last thing we need to do is at some point in time, in response to an event, add the event listener so that when the button is clicked, we fire the handle click function. Okay, so to do that, let's add a creation complete event handler. So this is when the creation complete event fires on our application, we're going to run this block of code. And
when does that happen? That's just after it finishes painting everything on the screen?
Yep.
Okay.
Yep. So now we're going to say button. We're going to refer to it through its ID, B. That's just its variable identifier. Add event listener. And we need to tell it what type of event we're interested in. We'll see we code completed all the possible events that we could be listening for on this button. In this case, we're interested in the mouse event dot click. Okay, and then we're going to tell it what function we want it to call when that event triggers. So what we're going to specify is handle click.
So that's very specific. Now, could you also just say any mouse event, or would you have to enumerate them?
You would have to enumerate them.
Okay.
There is no wild card. They have to be set explicitly for the specific event.
Okay.
So what we're doing now is we've just done something kind of interesting here. We've actually passed this function as if it looks like a variable, right? I mean, this looks like we're passing a variable, but it's really a function. And the reason why we can do that is that functions really essentially are variables. They're classes.
They're objects.
They're objects, right? Yep, just like a variable. And so we can pass these things around as references. And so what's really happening is we're giving this event handler or this event listener a handle or reference to this function, so that when this mouse event.click fires, it's going to then just call this function. Mm-hmm. If we took this mouse event parameter out, then we're going to get I believe a runtime error. I don't know if it's going to give us a compile time error. No. So at compile time, it doesn't know that we need that. But at runtime, when it actually tries to fire call this function, it's going to be trying to pass it a parameter that this function hasn't specified. We're going to get a runtime error.
Now, it's worth pointing out that this ability to take handle click down here and just pass it in, that's something you can't do in Java.
Right. Yeah, you can't just pass methods around. The references to methods around like that. Yeah.
Yeah. So.
Yeah. Okay, so now let's run this thing and make sure it works. So there we have our button, and when we click me, there we go. We get our click event fired.
Right.
It's exactly what we hoped it would do. The reason for that is that we've added our event listener to the click event, and then it's when the button is clicked, when it fires that event, calling that function.
Try commenting it out. Let's see what happens.
Okay, let's comment it out and reload, and nothing happens, and that's good. So there's some other things that we can do with event listeners. We can remove event listener, so we can do b.remove event listener, and then we specify the same parameters when we remove it. And
now, do you care what it was attached to before? You have to actually say remove it.
Yeah, we're telling the button to remove its event listener to that event, pointing to that function. So now it also should not work because that event listener doesn't exist. You do have to be somewhat careful with these event listeners, and this is actually probably the number one place for memory leaks in Flex applications, is that if we go look up here at the defaults on add event listener, we see use capture, we see priority, but here's the interesting one. Use weak reference, the default is false. So what's going to happen is that we could potentially be adding event listeners to things with this default of use weak reference equals false. And then if we try to remove that button, so let's say we don't need the button on the screen anymore, we remove it. Well, guess what? That button is not going to be garbage collected until all the references to it are gone. And so this, by default, will keep that reference onto that button and not allow it to be garbage collected. So we do have to be careful that when we want to remove this, we either use weak reference equals true, or we have to manage our event listeners and always remove them before something can be removed and garbage collected.
Now, what we're looking at here in the box, is this the actual argument list that comes from the function definition?
Yep.
So these equals false equals 0 equals false. These are default arguments.
Yep, they are default arguments.
So you can let the defaults be there, or you can
override them.
Yeah. Now, is this a positional thing? In other words,
it is positional.
So that
if I wanted to specify use weak reference equal true, I'd have to also specify use capture and priority before I specified use weak reference equals true.
Okay.
Yeah.
All right.
So and anyone can create these optional parameters on their functions. So if we wanted to go add an optional parameter up here, we could say, foo, string, or whatever type we want, and that this in this case would be a required one. To make it optional, we could give it a default value of foo whatever, and then there's also a way to allow you to specify any number of arguments.
Variable argument list.
Yep, a variable argument list. It's like foo, and you do like dot or something like that. I don't remember the exact syntax, but not used very often. But there is a way to do it to specify any number of arguments. Allow the developer to specify any number of arguments when they call the function.
Okay, so you mentioned before, and we've been talking about all of these events that are happening while the application is being created, and while it's running, and when it's being destroyed.
Right.
That's the component lifecycle?
Yep. Yeah, that's controlled by the Flex component lifecycle.
Okay, and that's the is that the Flash virtual machine that does that?
No, it's actually the Flex framework. So the whole UI component framework in Flex has this lifecycle that all components go through. And so the life cycle is there really for performance reasons, because we don't want to be doing this stuff over and over and over again. So what we do is we do some stuff and then we dispatch an event, and that triggers other stuff to do some stuff and then dispatch events. And so those events can trigger other things to happen, which causes more code execution to happen, which causes more events to be triggered.
But eventually those are done.
And those are all done.
Okay.
And then the application just sits there waiting for more events.
Okay, so it's kind of like a state machine saying, okay, first I'm going to do this, then I'm going to do this, then I'm going to do this, and then I'll sit there and wait for input.
Right. Yep. Yep.
Okay.
And so at the end of every point in the component lifecycle, it's essentially waiting there and waiting for the flex component lifecycle to tell it to do the next thing. And it could just be sitting there waiting forever until the user clicks on something, or the user resizes the browser, or there's all these different event listeners that are then going to cause different parts of that lifecycle to be triggered again.
Okay, so these things like, well, for example, we've got creation complete here, which is something that the framework fires automatically. Now, are these things fixed, or can I override their behavior?
Yeah, you can definitely override them. So application, it has a function on it called create children. So let's take a look at overriding the create children method. So I'm going to create a script block here. And in this script block, let's first import mx.controls.label.
Presumably you're going to define a label.
Exactly. So let's now override.
Okay, that's a new keyword we haven't seen.
So override, just like in any object-oriented language, allows us to override this function for this this class.
Actually, it's not in any object-oriented language. It's only in some of them.
Okay, in some object-oriented languages.
But the nice thing about it is that it helps you not accidentally redefine something.
Right.
So it's a little bit more explicit.
Right. Okay, so let's go in and set override the protected function create children. So what we're going to do is this application, or this ActionScript class that extends application, it knows that when it fires this create children method in the component lifecycle, that it's going to create whatever children it needs to create. And what we want to do is override that behavior, but we still want it to preserve the things that it's doing.
We don't
internally.
want to eliminate what it did before,
exactly.
or it won't create children.
Yeah, exactly.
Okay.
So what we're going to do is call super.createChildren.
So super is a keyword.
Yep. And so that's going to tell that's going to have it run applications create children method, right?
And you're doing it first because probably you want to take care of all that stuff.
Yeah,
and then you'll have something to work with.
Exactly.
Right.
Yeah. So I want this application to make sure that what it needs to do happens. And now I'm going to do my custom stuff. So in this case, I'm going to create a label. Just initialize that. And then we're going to set the labels.
So there's no way to do that in the constructor? You can't just say new label hello world?
If you try to do it in the constructor rather than on the create children method, it's going to be too early to add stuff to the application. Because there's that component lifecycle, there's only certain points in time when you can...
No, actually I meant just in here, in the new label. Is
right.
There's no argument for a string?
Let's go see if there's anything on the constructor that would allow us to set that label and avoid that extra line of code. So I'm just going into the ASDoc for label.
How did you get there?
I clicked on label, and then I hit Shift F2, and that's taking me now into the Flex Builder help, and so that we can see the properties on label. Okay. So let's go see. It's pulling that up.
Or presumably that's Shift F2 on a Windows machine, but something else on other machines.
Yeah,
you have to discover what it is on your own
that's right.
machine.
Yep. So what we're going to look for here on label is if its constructor takes anything that would set the text property on the label. So let's go see down here. It's going to be in our methods, I believe. So here we go, labels, constructor, and it doesn't take no arguments. So we do have to set that that label text like that. Okay, and now let's do this.addChild, which we've seen before. We're going to add label to the display list essentially, so that it gets displayed in the application.
Okay, but when does this function get called? I mean, this is just a definition. It doesn't say when it's going to be called.
So it gets called inherently in the Flex framework, because in that component lifecycle, there's like 7 steps in the lifecycle or something. You know, there's an initialize, and you can override things in initialize. There's the create children. There's update display list. There's a measure method. There's all these different methods in the lifecycle that you can just let them work how the Flex framework wants them to work, or you can go in and override them like we're doing here.
And because we're overriding this specific function named create children, we're changing its behavior.
Yeah, we're hooking into a certain point in the lifecycle. If we tried to do this earlier in the component lifecycle, it's going to throw errors, because we're going to be trying to add this label to the display list before that display list is even being created. Right. And so that's why it's important to, when you get into this level of Flex programming, to know when in the lifecycle you can do certain things. And there's great examples out there for how the component life cycle works and when you should do certain things in that life cycle.
Is that, for example, would you find that in Tour de Flex? Do they have
Tour de Flex would be some good examples of that. Also, there's great documentation in Flex's documentation on the component life cycle. So yeah, if you just went into the Flex Builder help and searched for a component life cycle, you'd find that information.
Okay. So
let's go run this one and make sure that it works. So there we go. There's our hello world.
Okay. Put it up there for us. The overriding. Okay. Well, the last thing I'd like to know about is so ActionScript is a statically typed language, but we can sometimes, when it's convenient, we can turn that static typing off, which is a very nice feature, right? Because normally, if you have a statically typed language, you have to jump through all kinds of hoops if you want to do something a little bit more dynamic.
Right.
And here, we can just effectively turn it off. Now, but sometimes to kind of go back and forth, you need to be able to cast. How do we do casting here? Because it's different.
Yeah. So I'll show you a quick example here, a little bit different than the one in the book, but I think it'll make sense here. So let's say that I remove my type information from this label. And I can compile this. As you mentioned, we're going to use the dynamic typing here. We don't have to specify the type on this label. We're going to get a warning saying, we probably should specify the type. But now we're using essentially the dynamic typing. If we try to do code hinting on this label, it's not going to know the properties on that. So one way that we can do casting is to use this as operator. Is that what it is? An as operator.
Mm-hmm.
And actually cast that label now to being a label. And now we should get the code hinting. Now it knows that it's actually a label again. Okay. So that's one example. Let me show you another example of how we do this using the example in the book. So what we're going to do is, let's remove this. I'm going to create a button and set the label to show, and set a click event handler to handle click, passing it event, and we will define that function now. So let's create a private function handle click. Give it a parameter event of type event and returns void. Now let's do var x is an int equals to, and so now what we want to do is set this x variable to the stage x property on our event. Mm-hmm. So if we try to do event.stageX, it's not gonna. It doesn't know what that is. If we try to save this, it's going to give us an error saying it doesn't know what this property StageX is because it doesn't exist on event. So even though mouse event, which is what's actually being passed in here, mouse event has this StageX property. What's happening is that when that gets passed in here, it's
not enough information.
Not enough information. So one thing that we can do is we can now just cast this event property using that same as to mouse event. So now we're essentially upcasting this or something like that. We're just telling Flex.
Actually, that's downcasting.
Downcasting.
Yes.
Downcasting.
Because you're going from more general to more specific.
Yeah. Right. So we're downcasting event to mouse event, which is, we know it's a mouse event because it's been triggered by this click event, which is always passes a mouse event. And now things will work fine.
But now the IDE is able to recognize it.
Absolutely, yeah. And we could even get the code hinting now, like we showed before with label.txt. So now we actually see state checks there.
Okay.
Yep. And then there's also another way to do casting, and I'll show you that. So let's add we're going to add an alert. So we're going to do alert.show. And now what we're going to alert is going to be, we just want to essentially display some information about these events. So to do that, let's do string. So we're going to cast this event to a string, and we're going to tell it, or what we're going to do is say event is. So we're doing actually a comparison here. Is that a comparison? The is operator is going to check to see, is event a mouse event? Okay. So then let's also, just for fun, add in the string x as well. So there's actually two different casts going on here. First one is we're taking this thing that is going to output either true or false.
Oh, so that's a test. Okay.
That's a test. Test is event a mouse event,
and that returns a boolean presumably, and to make it print out we need to convert it to a string.
Exactly.
Okay.
And then we're going to put a space in there, and then we're going to cast this int to a string as well.
Okay.
Okay. So let's save that and run it. So show. So we get true, and 513 was my x position, my stage x when I clicked that button. So if we go back here and look at the code, what's interesting is that this was true even though event was of type event. It really was of type mouse event.
So this is basically dynamic type checking.
Right.
Yeah, it's runtime type identification.
Right.
Is what it
Yep.
is. Okay. Nice.
So that's two different ways to do casting. One is the as operator. One is the syntax that looks like we're giving this thing to a constructor. I personally use as because I think it's a little bit less, a little more readable than this one. Sometimes I get confused if that's a constructor, calling a constructor or not. And then the as and this syntax work differently if the values are uninitialized or null or something.
Well, the as is a force cast. In other words, it's saying treat this as a mouse event, and then the compiler accepts it. It still could be wrong at runtime. Whereas what you can do with is say, hey, I don't really know what this is, so is it a mouse event? And then so what you could do is say, is it a mouse event? Then I'll cast it to a mouse event and then treat it that way from then on.
Yeah.
Okay, and well, the book will give you further learning links when you have other questions.